Okay, so where have we seen these? Have we really seen number 1 before? Ax plus by plus c equals 0? Not really, right? What about standard form? Ax plus by equals c. One we have, actually. We just haven't used it a lot. But what about the next one? Slope-intercept form.
Yes.
That one should be our most familiar form, right? Where have we used this? When have we used this form? Graphs, right? This we use primarily for graphing. Let's remind ourselves, what does the m represent? Oh, so that is correct. What does the m represent, though? It is our rate of change. What do we call it when we're dealing with a linear function? Slope, right? So the m is that slope, which is our rate of change. What does the b represent? Y-intercept, right? So this one should be the most familiar. Have we seen the fourth one, point-slope form? Probably haven't, but that is going to be our other important one for this class. Point-slope form. And this one is the one that I want you to use when we practice writing equations. You can use your point slope, and that's what you probably have used for other classes when we write equations, but I want you to try out this form. So we're going to use for writing equations. And in this form, we are given our slope, so m is still the slope, but we are also given a point, which in this case x1, y1. All right? So those are going to be the two most important forms that we're going to be concerning ourselves with this year. Now, we do want to make sure we note that if we have just a equals a number or y equals a number, those are either vertical or horizontal. X equals a number, so it'll say like x equals 5. If you're asked to graph x equals 5, that is a vertical line. Y equals -2, be a horizontal line. Okay? Sketching graphs of linear functions. We use our slope-intercept form. That should be familiar, so I want you guys to go ahead, take a couple minutes, get your graphs for each of those down in your notes. Sketch out, use your slope-intercept form, and what is our graph look like? All right, let's go ahead and graph these. Gabriel, help me out with the first one. Where would I start? -1? And then where would I go? So yes, so remember we have our slope is 2, which is 2 over 1. Remember we always think about this as 2 over 1. So that if I go from these 2 points, have a rise of 2, a run of 1. So up 2 over 1. And I can do that multiple times. I can even go in the opposite direction, down 2 and left 1 to get other points. That should give me the points that I have. Again, that should be review. We've been doing that since at least Math 1, so shouldn't be anything crazy there. So our B was our y-intercept at -1. All right, let's go ahead and just quickly do our next graph here. Mandy, how would I go about graphing graph B? Start at 3, okay? 3 to the left and then 2 down. All right, so if I go 3 to the left and 2 down, does that look like a graph that's increasing or decreasing? What do you think? Is that an increasing or decreasing graph? Increasing, but what is our slope? Is our slope positive or negative? Negative. Now, this is something that we need to remember. If we have a negative slope, what should our graph be doing? decreasing. So one slight change on that, Mandy, is that instead of down, we would want to instead go up. So we have that decreasing slope. And so that's where we need to remember that this negative doesn't mean I do the opposite, right? Because 2 over 3 would think up and right. So negative 2 over 3 doesn't mean down and left. It means we do the opposite on one of them. So the negative 2/3 means either we have negative 2 over positive 3 or positive 2 over negative 3. If we were to go down and to the left, that is actually negative 2 over negative 3, which is actually equivalent to a positive slope. Negative divided by negative is a positive. So one or the other, down and to the right would work, or up and to the left, or left and up, whichever way you want to look at it, would also work. Either way, we would get that nice negative slope. All right, any questions on that? Just a reminder on our slopes. Okay, let's go ahead and go into problem 2. So problem 2 and A and B, you've probably done it in a slightly different way. I want you guys to use, and on your homework, to practice using that new form of the point slope form. So y minus y1 equals mx minus x1. Now, it can be done using the slope intercept, y equals mx plus b. But we want to get used to this. This is something that's going to crop up a lot in our curriculum. And when you move on to calculus, either in college or with me, we'll be using that form a lot. So this is a form we want to make sure we're familiar with. So this form requires a slope and a point. Well, here's our point, x1, y1, and here's our slope. So if I have y minus y1 equals mx minus x1, y minus, what's our y1? Jet, what's our y1? What did I label as y1? So that would be y minus negative 4. Slope, what are we given as our slope? Cat, what's our slope? X minus, and then x1. What do I have labeled as x1, Sophia? 8. And then all we want to do is simplify that down to get my y equals mx plus b. All right? So I'm going to go ahead and distribute in my 2/3. So that becomes y plus 4 equals 2/3 x minus, and then that should be 16/3. We think about that as 8 over 1, and we're multiplying. All right, if I want to get y by itself, Brandon, what would I need to do to get y by itself? Subtract our 4, right? So minus 4 on both sides. I'm going to go ahead and do that fraction operation over here. So we have negative 16 over 3 minus 4. Put that over 1. What would be our common denominator, ladies and gentlemen? So times top and bottom by 3. Negative 16/3 minus 12/3. What would be our result from that? Negative 28/3. So my answer, y equals 2/3 x minus 28/3. There we go. Again, it can be done other ways. This is not the only way. You might know it a different way, but I want you to practice using this form. Any questions on that? All right, let's go ahead and look at B. So if I'm going to use my y minus y1 equals m x minus x1, what are we missing? What do we need? M, our slope. But can we find our slope? Yes, we can use our slope formula. We can also think of it in terms of our difference quotient from yesterday, f of A, B, f of B. So we can find our slope by doing f of B minus f of A over B minus A. So exactly what we were doing yesterday, slope between 2 points. Or you can think of it as y2 minus y1 over x2 minus x1. Regardless, gives us the same thing. All right, Daniela, what would I have in the numerator for that slope? 5 minus negative 15 over 6 minus. Okay. One thing I want us to look at. Do 5 and 6 come from the same point? There you go. Do they come from 5 and 6? Do they come from the same point? No. So these swap, right? Because that should be f of b. If you do 5 first, and you can, then these would have to be swapped here. So you'd have to go negative 4 minus 6. And that's fine. That would work. But let's go ahead and flip the top so that matches up with the denominator there. So negative 15 minus 5. All right, what's negative 15 minus 5, ladies and gentlemen? Negative 20 over, which is? So we have a slope of negative 2. And you can go ahead and use one of your points. It doesn't matter which one. Let's go ahead and use the first one as x1 and y1. So if we have our slope now at negative 2 and our point negative 4, 5, I want you to go ahead and enter in your equation, find out what our equation would be. All right, so go ahead and try that out. All right, check your work against mine. So using my point, that should be y minus 5, negative 2 for the slope, x minus negative 4, which would be, so y minus 5 equals negative 2, x plus 4. Distributing my negative 2, y minus 5 equals negative 2x minus 8, and then I add 5. My final should be negative 2x minus 3. All right, so double check your work. Make sure it matches out. And regardless of how you did it, whether you use point slope or slope intercept, it should come out to the same thing. All right. Any questions on using our point slope form? All right, go ahead and flip the page. So this next, problem number 3, we're actually going to skip problem number 3, but I do want to, anytime that you come across parallel or perpendicular, reference it from here. Parallel lines, slopes are equal. We see that in these two equations. 1/2, 1/2. Equal slopes are parallel lines. Perpendicular lines, slopes are opposite reciprocals. If we look at that, we have 2/3, negative 3/2. Fraction flipped and sign changed. That's an opposite reciprocal. So if you ever see slopes with opposite reciprocals, it creates perpendicular. What does it mean to be perpendicular? Anybody remember? Right angle. So it crosses at a 90 degrees. Okay, 90 degrees, perpendicular. All right, let's skip over that. I want us to come down here for the last little bit that we have. All right, so we are going to first off fill in this table. We won't use our calculator. This is easy. We can do this by hand. So, negative 3 times negative 2 plus 7. What's negative 3 times negative 2? 6 plus 7 is? 1. There we go, Tyler. All right, next one. Negative 3 times 3 plus 7. What's negative 3 times 3? Plus 7? Negative 2. All right, negative 3 times 4 plus 7. What's negative 3 times 4? Negative 12 plus 7 is? Negative 5. 12 minus 7 is 5. Negative 3 times 8 plus 7. What's negative 3 times 8? Negative 24 plus 7. Negative 17. All right, negative 3 times 10. What is that? Plus 7. 23. All right, what we want to do. Each of these are what we call sub-intervals. I am not done. You should not be like thinking you're done. Each of these are what we call sub-intervals. We want to find the rate of change over each of those sub-intervals. So, from negative 2 to 3, our rate of change would be 13 minus, actually no, we would go, f of 3 minus f of negative 2 over 3 minus negative 2. F of 3, that is negative 2. F of negative 2 we said was 13 over 3 plus 2. What's negative 2 plus minus 13? Negative what, guys? 3 plus 2? All right, negative 15 divided by 5. Negative 3. Negative 3. All right, in the last couple minutes, I want you to find the rate of change for the next set. So for 3 to 4, what is our rate of change? So our rate of change for the next interval is from 3 to 4 is also negative 3. So I want to go ahead and calculate those other ones as well. So we have, I'm going to do that, save a little bit more space. So I know the setup, so I'm just going to go, so I'm looking at these 2 points now. So that'd be negative 17. Negative 17 minus negative 5 over 8 minus 4. So that should be negative 12 over 4, which is negative 3. So that those two are also negative 3. And then our last one is these 2 points. We would have negative 23 minus negative 17 over 10 minus 8. And that should give us negative 6 divided by 2, which is also negative 3. So it turns out that the average rate of change of all those intervals, every single subinterval that we're given, was negative 3. And notice what all of these match. Well, they match that slope of the line, that m that we had, that mx plus b. So let's see if that happens again on this one over here. And I'm going to go ahead and use my calculator. Actually, yeah, I'm going to go ahead and use my calculator to at least get the table. Here we go. So in my y equals, I'm going to go ahead and clear each of those out. And I'm going to have 3, oh, what happened? There we go. 3 halves x minus 5. And I'm going to go ahead and just, actually I can use my table feature like we looked at earlier. So I'm going to go ahead and I need negative 8. So negative 8, give me negative 17. Negative 2 gives me negative 8. 0 gives me negative 5. 4 gives me 1. And 6 gives me 4. All right, so let's go ahead and look at the average rate of change over each subinterval. So starting with these two. So looking at those two numbers, again, to save up space, I'm just going to go ahead and set up my difference quotient. So that'll be negative 8 minus negative 17 over negative 2 minus negative 8. So I'm going to go ahead and do some of that there. So that would be negative 8 plus 17 gives me 9 over 6, which reduces to 3 halves. So again, matching that there, 3 halves. So let's go ahead and do the next one. So these two subintervals. So look in there. Yeah. All right. So that would be negative 5 minus negative 8 over 0 minus negative 2. That should give me positive 3 over 2. So 3 halves again. All right. Let's go ahead and do the next two. Those there. So that should be 1 minus negative 5 over 4 minus 0, which give me 6 over 4, which again reduces to 3 halves. So those two were 3 halves. And let's go ahead and do the last two. So that should be 4 minus 6. Oh, nope, sorry. Putting the x values on the top, y values go on the top. So 4 minus 1 over 6 minus 4. And that is, again, 3 halves. So it does match, 3 halves. And so when we're finding the average rate of change for linear functions over any subinterval, it should be the same, matching my slope of the function. So that is actually answers our question down below. For a linear function, the average rate of change over any length input value interval is constant, or is the same. Okay, it's an interesting way of phrasing things here. It says over any length input value interval. So we had those subintervals that we had. And so looking over each of those intervals, input value intervals, they're saying any length. So that means that we don't have to be going up by the same amount. Okay, so if we had negative 8 to negative 2 was plus 6. Here, negative 2 to 0 was plus 2. From 0 to 4, that was plus 4. And 4 to 6 was plus 8. And so we can go ahead and see that that was plus 6, plus 2, plus 4, plus 6. And the same thing if we look at the other one over here, those are different lengths. So it doesn't matter what the lengths of our input values are, the distance between those input values, if we set up our average rate of change, they will be the same. They will be constant. So linear functions will always have a constant rate of change. Our average rate of change for linear functions is constant. So linear functions give us a constant AROC, average rate of change. All right. And so this concludes this video. Have a fantastic day.